Hello everyone, my name is G. Rishikesh Arya. I'm from CSC Regular. My roll number is 24011A0529. Today's topic of my presentation is three-phase balanced circuits, in specifically star connections, from the subject Basic Electrical Engineering. So let's dive into it. Introduction to three-phase system. A three-phase system is widely used in power transmission and distribution due to its efficiency. It consists of three alternating currents, all having the same frequency, but phase differences of 120 degrees. The system provides more consistent power delivery compared to a single-phase system. The three phases are typically labeled as phase A, phase B, and phase C. Three-phase systems can be connected in two types: star configuration, and delta configuration. Here in our presentation, we focus on the star configuration. The star connections offers advantages like simplicity, less voltage per wire, and easy ground reference. Now coming to understanding star connections. In a star connection, all the phase windings are connected at a common point known as the neutral point. You can observe the diagram given in the left. The other ends of the windings are connected to the phase conductance mentioned as L1, L2, and L3. The neutral point is often grounded to provide safety and reference for the system voltage. The voltage across each phase, line to neutral voltage, is lower than the line to line voltage by a factor of root 3. That is, in mathematical terms, it can be written as line voltage equals to root 3 times phase voltage. Line voltage is equals to root 3 times phase voltage. This configuration is most commonly used in low voltage applications such as residential areas and small industries. Balanced load in star connection. In a balanced load scenario, all three phases carry equal currents and voltages, and the system is perfectly symmetrical. A balanced load means the impedance in all three phases is equal, i.e., the circuit may contain resistance, inductor, and capacitor. The impedance of all everything should be equal, ensuring that the current and voltage remain steady and equal across the phases. The current in each phase will be the same in magnitude but differ in phase by 120 degrees. If you observe the diagram here, given Ix, Iy, and Iz, the phases are differing by 120 degrees, which can be drawn in two ways. This is the phasor diagram of currents in a balanced three-phase load. Coming to calculating power in a balanced three-phase system can be given as P is equals to root 3 times V line voltage into line current into power factor, where power factor can be written as the cos phi, and where phi is the phase angle between current and voltage. A balanced system is essential for optimal performance and avoiding issues like harmonic distortion and overheating in electrical equipment. So balanced load prevents by short circuits and everything. Single phase, using single phase is somewhat degraded when using three-phase system. So three-phase system is considerably used in residential areas. Coming to advantages of star connections, lower voltage requirement. In star connections, the voltage between any phase and neutral is lower than the line-to-line voltage, making it safer for equipment. Efficiency in power distribution. A balanced three-phase system allows for better efficiency as the power delivered is smoother and more continuous compared to single-phase systems. Simplified grounding. The neutral point in the star connection provides an easy and safe path to ground the system, improving safety and system protection. Reduced transformer size. When used with a step-down transformer, a star connection allows for a more compact design. Cost-effective for power distribution. Star connections help minimize power losses and reduce installation and maintenance costs. Star connections has advantages and disadvantages both. So coming to disadvantages of star connections, neutral wire required. The star connection requires a neutral wire, which adds to the complexity and cost of the installation. This neutral is essential for grounding and provides a return path for unbalanced currents. While the phase voltage is lower, the line voltage in star connection is higher. So higher line voltage comes under a disadvantage of star connections, which may require additional insulation and stronger components to handle higher voltages. In case of poor grounding or faults, the neutral point can rise to high potential. So star connection has grounding issues, posing a danger to equipment and personnel. It is crucial to have proper grounding to ensure safety. Star connected systems are more sensitive to load imbalance. So imbalance sensitivity is another disadvantage of star connections. If the load on each phase is unequal, it can lead to issues like voltage fluctuation, overheating, and reduced system efficiency. Limited power delivery for large loads. Star connections are typically used for lower voltage, lower power applications. For high power distribution, a delta connection might be preferred due to its ability to handle larger loads. Coming to voltage and current relations in star connections. In a balanced three-phase system, all phases carry the same current and voltage, ensuring uniform power distribution. The phase voltage is the voltage across each individual phase from the neutral point. The line voltage is the voltage between any two of the three phases. So, the relation between the line voltage and the phase voltage, line current and the phase current in a star connection is given by, as previously discussed, line voltage is root 3 times phase voltage. And in star connections, line current is equal to phase current. While when we go to delta connections, line current is equal to root 3 times phase current and line voltage is equal to phase voltage. So in simple terms, star connection always tries to equal the current and delta connection tries to equal the voltage. This property allows for better load distribution and simplifies the design of the system. For the testing of our concept, problem, a three-phase system is connected in a star configuration with a line voltage of 415 volts and a phase current of 10 amperes. If the power factor is 0.8, calculate the total power delivered by the system. So analyzing the given data in the problem, we we got the information that line voltage is equals to 415 volts, phase current is equals to 10 amperes, power factor alias cos phi is equals to 0.8. So now to calculate the line to line power using the formula, total power is equals to root 3 times line voltage into line current into cos phi, which is also known as power factor. So as we know, phase current is equals to 10 amperes and it's a configuration. So phase current is equals to line current in the star configuration, which we are going to use to solve the problem. So total power is equals to root 3 times 415 volts into 10 amperes into 0.8, which is equals to 1.732 into 415 into 10 into 0.8, which is equals to 4792 watts. So the total power delivered by the three-phase system is approximately 4.79 kilowatts. So now to conclude and some other key points regarding the star connections. A three-phase star connection offers a reliable and efficient method for power transmission and distribution. It helps balance load, reduce power loss, and improve system stability. The phase and line voltages are related by a factor of root 3, and the system supports a balanced load for optimal performance. Proper power calculations are crucial for determining the system's efficiency and safety. Star-connected three-phase systems are commonly used in low-voltage applications, whereas the delta-connected three-phase systems are used in high-voltage applications. Star-connected users are used in low-voltage applications due to their simplicity and safety advantages. Understanding the relationship between voltage, current, and power in a star connection is essential for designing and troubleshooting three-phase systems. In a star connection, one end of each of the three phases is connected to a common point called the neutral, while other ends are connected to the load. This gives us a stable configuration. That is why it is used in residential areas. So ending the presentation with a powerful quote about star connections. Powering efficiency safely and steadily, the star connection advantage. Thank you.